You look at this and you look at this and wonder, what in the world is all of that stuff? It looks like a quadricopter flying over a plastic model of a helicopter, stuck on this long boom that has a counterbalanced weight, and then, gee, a whole bunch of contact assemblies that'll allow you to rotate and still maintain contact, and transformers and power supplies and great big power transistors. You have to put yourself back about 40 years ago when you didn't have little MOSFETs that can pump 10 amps in a TO3 case. You had to have a TO3 case transistor like that to handle a few amps. They did have some pretty good RC radios starting out then. This is one of the classics if you're from the Dallas-Fort Worth area. Why, EK Logical in Irving. That was a real popular radio back in the time, and it's actually kind of wandered out of use by 1980 as this was built, and the case was repurposed to supply the electronics and control to make this simulator. It's an RC simulator that has, for tail rotor control, like some of the newer electric helicopters, well, they've been doing it for quite a while, 20 years probably, uses a electric motor in the back that it reverses direction on to control yaw. And then roll and pitch are just four motors like a quadricopter. You speed all four of them up, and it lifts up, and then you speed up one more than the other, and you get tilt and pitch. Okay. Now, as you can see, being on an arm like this, why you don't have complete representation of a flying helicopter, RC helicopter. But if you visualize, in this case, where it's in line with the counterweight boom, why pitch wouldn't do anything. I mean, it's not going to go anywhere. Okay, but roll, if it was like this, wouldn't go anywhere. But if you're rolling, okay, back and forth, it is representative of what an RC helicopter would be. The whole point of this whole experiment was to learn how to nose in fly the helicopter, to be totally oriented to it, and that took a little while to do. Now you just download a piece of software on your computer, and you get perfect representation of what it's like, and you can learn and crash all you want. Doesn't cost you anything. But back when my first helicopter was a Heli Baby, I think I bought the rotor blades by the dozen. Anyway, in this case, I found it to be very, very useful. I built this just to learn to nose in, is I would take a fan and set a fan off behind it, and as I would lift off, I would do hovering 360s in spot. And as it went around, if you're going to keep it in the same spot, if the fan was back here, you would have to roll it that way and keep it in position, or it would blow this way. Okay, as you rotated it around, when you got to here, the fan would blow it forward, so you'd have to pitch it up. So if you sat there and did hovering 360s with it, you pretty quickly caught on to when you needed to apply control to compensate for the direction. I see my camera's getting off here a little bit. Anyway, but building it was more of a mechanical venture than anything. And you can buy slip ring assemblies like this fairly cheap. But this of course I had to make using brass and some steel wire for contacts. And I was looking at this. I built this long 45 years ago. And the pivot point for the helicopter to give it some movability is an 049 piston. I thought that was kind of cool that I thought that up. Anyway, but you got a contact assembly there, and you also have one over here. Okay, so that the boom can rotate around. Here is so the helicopter can rotate around. Okay, the electronics basically there's a couple of op amps, old LM324 op amps inside this case that creates the mixing to drive those drivers to run the motors. So there's you've got 4 motors you're driving on the quadricopter part of it, and then you've got your tail rotors. You got basically 5 systems you're driving. And as you bring up the collective power, why it applies power to all 4 motors, and as you give, let's say, if I can get this in that camera, you pitch it forward, it's going to apply more thrust on the back motor. It'll pitch forward and so forth. It took me quite a while to build this. And to give credit, this is not my design. This was originally designed by the first AMA RC helicopter world champion, Hubert Bittner. He and I think it was in 1978, he won the first nationals. And I talked to him recently, and he had learned to fly nose in and stuff before he built this, but he just had some interest in simulators and for multiple reasons, even for teaching real helicopter pilots. So anyway, so this is the gist of it. I'm getting ready to take it apart and throw it away. It takes up too much room. This was stored in a friend of mine's attic, and Peyton Enlow's attic for 40 years, and to my surprise, he still had it. So I brought it home and I resurrected it. All the electronics I'm going to guess I don't have the schematic anymore, so it would take me 3 or 4 days just to generate a schematic. But I'm not sure if the motors will even. They kind of do stuff. Tail rotor works a little bit. Whoops. Okay, but it's really not. It's not up to snuff, to say the least. Okay, and it's not worth my going through the problem of fixing it. But I made a minimum effort. I put all the wires back together and made a minimum effort to make it work. But it's just not. It's not in the making, and I'm not going to spend that much time doing it. Apologize for the video here, wandering all around. But that's the gist of it. I want to kind of archive it for myself. I put these videos up on YouTube more for my own archival purposes than for anybody's entertainment. But hopefully you enjoyed seeing what it was like in 1980 to learn how to fly an RC helicopter.